Hey, good evening everybody. Welcome to Meteorology Lab. Here's a bit of time-lapse from last winter. That's about all we have to look at right now. But very photogenic there. Nice seeing those colors out there. So how's everybody doing? Let's check out the charts. And we got a little bit of action out there on the Great Plains today. We'll switch over to that here. There it is. Little cell out there around Elk City. We can take a closer look at that on the radar. I've got GR level 2 going here. There it is right there. So that's not very impressive. So not only do we don't have very strong intensity in this cell, we've got almost no gradient along the edge. So this is a very weak storm at this time. I didn't have a chance to check it out earlier. It does look like it was a little bit more intense back maybe an hour ago. But anyway, let's head into the surface analysis and see what's driving the circulation. There's our front there in the Central Plains. That in turn is being driven by this 1024 millibar high up along the U.S. and Canadian border. So this is causing a push of cold air coming south all the way from the Rockies out to the Midwest. And this has been sort of a stationary front. It's sagged south over the past day or so. And then out in Texas, it looks like we have maybe a bit of a dry line coming together in that region. The only way we know for sure is to look at the surface analysis. And let's check it out here. We do have the better moisture coming northward. There's those 60s dew points coming up I-35, making its way all the way up to Enid, all the way up to, yeah, certainly Medicine Lodge, Wichita, and Salina. Okay, so what happens when we go west? Well, the moisture does fall off a little bit down at 57 at Woodward. Falls off a little more sharply around Altus. So that tells us maybe some moisture depth problems. Down to 53 at Childress, and then 23 to 25 at Plainview and Amarillo. So where's the dry line? A lot of people may go by the wind flow. See how the wind flow is kind of doing that right there, contrasting with these southerly winds. So one possibility is to put the dry line in between. But we've got to keep in mind the primary definition of a dry line is a gradient of moisture. So we've got to be looking at that gradient there. And yeah, we definitely do have a gradient along the cap rock. But, you know, I'm kind of troubled by these 50s dew points at Altus. So maybe the relevant gradient is out in this region here. So a couple possibilities there. You could place it back like that right there, or you could keep it to the west. So what you might do is look at the satellite and look at the scenario you have, and take a look at the trends and just kind of, you know, there's not really a cut and dry rule for everything. That's one problem we have in severe weather forecasting here. Anyway, so yeah, there's the current radar. We'll go ahead and continue with the rest of the analysis. Let's take a look at a couple of SPC products. Maybe we can take a look at the instability. Okay, there we go. Surface-based CAPE. It has definitely come up. We're looking at 2,000 to 3,000 there. Doesn't seem like it's much help for that storm there, so possibly something else is going on there. Let's look at the storm relative felicity effective SRH. That looks to be pretty poor, and that's likely a consequence of this veered flow in western Oklahoma there. Some of these other values I think maybe we can take a look at on the pivotal weather model products. That might be a better way of visualizing some of this, so we'll do that here shortly. Upper air chart, let's head into that. There's our big low there. It's about to park itself over the Great Basin area, and we can see that very strong jet max on the west side. That's going to be digging into the Four Corners area, and as it approaches the Rockies and the High Plains, that should increase the possibility of severe weather, maybe out around Amarillo and Dodge City this weekend. So we'll check things out here shortly, but this is a plunging jet max coming down the west side there, so that's going to kind of act to steer that trough down towards the Four Corners area there. Quick look at 700 millibars showing that, yeah, we do got a lot of capping. 15 Celsius cap where that storm is. 15 Celsius at 700 millibars. So that's indicating to me that there's probably a very strong cap there, and maybe the storm just cannot pull itself together because of all that inhibition there. Up to the north, the cap is weaker, but that gets back into that cold air mass. The front is all the way down in Kansas down here where the cap is strong. So that's one reason we're not really seeing much of anything. And then at 850 millibars, looks like moisture depth is probably still a problem. Fort Worth reporting -9. I think that's a -9 at 850. The better moisture down at Del Rio and Monterey, not so much on the coast or at any of these other stations. So moisture is a little bit scarce apparently still. Then that brings us to the thickness and isobars. We can make out our front from Illinois to the I-70 corridor out to Denver. That's probably going to be a quasi-stationary front, maybe something like that there. And then as we get out west, we've got a pretty strong front coming out of Utah and Nevada there. So maybe some north winds at Area 51 there. Maybe they're operating on runway 31. And up to the north, there's all that cold air up in Montana and Washington helping to feed that cold air advection north of the front. And we're still generating a little bit of cold air up in the Hudson Bay region. Looks like another backdoor front trying to come together, but it's starting to lose steam because we're getting into late spring here. All right, this is probably a good time to start looking at the satellite. And I'll start with the wide view here. So this kind of shows the visible imagery, the progression of all of these clouds coming from the west. Got all this troughing out in this region, so that's helping to really increase the cloud material in that region. But out in Texas, everything is driven by the dry line. And there you can see that anvil. And let's take a closer look at that. This is a 50 frame image, so this will be pretty cool. I haven't even seen this yet, so let's wait for this to load. It's going to flicker at first, and then we can watch it a few times here. But one thing that you can see here, there's a very what's the word I'm looking for? Out here in the moist sector, there's a tremendous lack of low cloud. Clear skies. So that tells me there's probably some moisture issues out in that area. Let's go ahead and set this frame at the very beginning. This is going to be about 3:47 p.m. and you can see those cells coming together around the McLean, and I guess that'd be south of Pampa there. It's got kind of a multicellular look there. And then as we roll that forward, you can see the cells kind of pulsing there, kind of like a little steam engine, cranking out that anvil. A couple cells further down along the dry line, but Seems like there was definitely some potential earlier, and putting out a very good anvil there. But just don't know what happened to it the past 30 minutes or so. Anyway, that's the last frame right there, and that's definitely putting out a huge anvil. All right. So I'll go ahead and run that animation for you, and I'll get caught up on chat here. All right, Ron Chalfant, welcome to the webcast. David Lumbert, there in Maumelle, 84 degrees. Ryan Toomey's says nasty weather is heading his way in South Florida from the Gulf. Thomas Fortner, cold and rainy in Sioux Falls with that cold air coming out of Canada there. Jack Benner here with Fun with Tech. Burl H, 54 in Iowa City. Erica Baker, Coffeyville, Kansas, 80 degrees. Strong south wind there. Jack Benner reporting a red flag warning there in New Mexico. And hello to David Moore there. Thomas Fortner says the sound is good. Electric Dog joining us, and Mr. Manlet. Very cold weather in Rockford. Highs only in the lower 50s. Wow, it's almost June here. And they're still in the deep freeze there. Okay, Mike Estwick is there, and Mr. Manlet says Rockford, Illinois, under a marginal risk. Brian says Saturday, possibly a good day to chase. Texas, Oklahoma, Kansas. SPC, damaging wind event for Pennsylvania, possible tomorrow, from Mr. Manlet. Jeff Krob, WindGrid's author, is here, and Dean Benedict. Jeff Krob says the new Ghost 17 first official image release has been pushed to June 4th. Michelle Curlin, watching Inside Out. Maximum crosswind component for a flying saucer at Area 51. I think that would be about 43 knots or so. That'd be about my guess there. Jeff Krob says, check out those gravity waves on the top of that anvil. Mr. Manlot says, don't forget to hit the like button. And Mike Estwick says 67 in Denver. All right. So, yeah, this is a good time for this. Okay, I use that time to kind of get my notes all set up and make sure I have everything in order. So let's check out our paper. So we're going to do, it's Friday, might as well do a little tornado-related paper here. This is October 2013 Weather and Forecasting. Josh Werman and Karen Kasiba. They're from Oklahoma City. Oh, okay, they're based in Boulder. For some reason I was thinking they were there at OU. Center for Severe Weather Research. Anyway, they've done some presentations at ChaserCon. Some good stuff there, so we'll kind of maybe go over some of this. This goes into different observations using the Doppler on Wheels radar. Some very cool stuff here. So let me go through this graphically, and this kind of shows some of the features that we see at very fine scales. Let me zoom in on this here, get a good look at this imagery. So there's a couple different categories of features that we see. One example is marginal tornadoes. The de facto definition with these types of radars here, they're looking for about 40 meters per second of shear. And These particular vortices here, these are only showing about 30 to 35 meters per second. And what we're talking about here, as far as these measurements, they use, let's see here, you can see in the paper dx, and they also have a measurement called dV. And this is a way of measuring these vortices. dV is basically you find the couplet that represents the tornado and measure the shear, the difference in velocity across that couplet, which is, you know, what we do on these webcasts using GR Level 2. So dV is just your difference in velocity across that couplet. And then dx is your, that's your distance. So in this case, it shows that the couplet is 2 kilometers in width. So that's pretty simple there. So we can use this to kind of get a handle on the different scales that we're seeing here. So yeah, this first figure, this is a marginal tornado located right in here, and it's only showing about 30 knots of difference across that. So would you consider that a tornado? I mean, there's kind of a spectrum there, and the stuff at the bottom end, you know, I'm not sure if that falls off or what. We don't really know the dynamics going on in this case here. They didn't see any funnels in this particular situation here, and it was listed as EF0. There was tree damage with this top one. So the structure of that particular vortex, that's kind of a mystery there. Here's another example. Well, actually, this is a different one here. This is multiple tornadoes with different mesos. This is the Protection Kansas event from April of 2007. And right there we can see 2 vortexes. And there it is right there. This is the reflectivity, and this is the velocity. And one thing that we're missing on here is the direction of the radar. It's kind of hard to distinguish that sometimes. I can see the radials here going on, which suggests that the radar is in right around here. So yeah, there's the outbound, there's the inbound. Okay, so that makes sense right there, but on some of these other graphics, it does get a little bit more complicated. But I'll point them out for you here. So this was a cyclic tornado event, and this obviously was the weaker. Yeah, is that, what am I seeing here? Yeah, that's the weaker one right there, and then there's these 2 vortices, and then we have a different event right here, and there's actually a photo here showing the south and north tornado. This is Hill City, Kansas, June 2005. And that tornado, that's the south one, located right here on the reflectivity and here on the velocity. And what this is showing us is that the north circulation here is a little bit wider and a little bit more intense, and the other is a little bit more compact. It only had a dx, a width of only about 200 meters. That's this one right here. So 200 meters on that, 400 meters on that one. That was a wider one and a little bit more intense. All right, let's see here. This is Goodland, Kansas, May of 2008. Quinter, actually, I'm sorry, I'm thinking of the radar. This is Quinter, Kansas, on Interstate 70 here. This is a multiple tornado event. And what we see here is kind of like a large meso, and there's these smaller vortices in here. And what we see with these multiple vortex situations is these smaller vortices, they tend to kind of dissipate, and then we get this, they kind of merge into this larger vortex here. So hang on a second, I'm referring to my notes here. And what you'll notice is that on this large vortex, that's about 1,200 meters apart there, and then these other smaller ones, these have a width of about maybe 50 to 100 meters. And then at the very end there, when the big tornado is coming together, it's kind of dominated by that large-scale structure there. So it's kind of hard to say how we would classify that. The people that were there described it as a wedge, or they referred to a second tornado, for example. And this is another graphic here. This was taken at 2136 UTC, and you can see there's kind of like dust whirls, and it's got that really ragged look, like you know something's going to happen there. It's got that look of like fast rotation underneath that wall cloud there, and that is right there. And those little vortices right there, those are probably these little whirls that we're seeing here, these little funnels. And then after that, the wedge itself starts coming together there. Okay, then that brings us to the Oklahoma Union event 2000. And you can see there's multiple tornadoes out here with a larger scale structure. So here's the reflectivity. You can see this is kind of on the cusp of a hook right there, and then to the north there's a little bit of updraft structure in there. And this is another case of smaller multiple vortex funnels merging into a single tornado. And let me see if I can see that happening here. Yeah, as you go down, this goes forward in time a few minutes, and then towards the end we can see that vortex coming together there. In this example, however, okay, yeah, that's about all I got for that one. Let's move on to the next one. This is the Binger May 2003 event, and multiple tornadoes around the cusp of that hook. You can see them right there. However, no funnel was seen in this particular event. It was dark, and it's not clear if there was a tornado on that one. Then we've got this next sequence here. This is Seward, Kansas, in May of 2007. Multiple tornadoes. And this is an example of a very large and intense circulation that's kind of hard to classify. So you can kind of see right here in this graphic, this is velocity, and you can see that there's this large, very broad, very intense rotation dominating things, and then there's this very strong vortex right there. It's kind of like an embedded vortex. It was dark, and it was raining heavily. It was impossible for the people that were out at this time to see the whether there was a funnel or not. The Weather Service called this a EF1 tornado that was 230 miles wide. So again, you know, what do we call this? Do we call this a single large tornado, or a event from multiple small tornadoes? This one here is the Chickasha tornado from May 3rd, 1999. The big outbreak in central Oklahoma there. Multiple tornadoes within the same meso. And you can see out here there's this tornado off to the side that's kind of orbiting around the main one here. It's kind of similar to what we saw on May 10th of 2010 in Norman, when we had that satellite tornado that was south of Highway 9 there that hit that supermarket. This example here, again, multiple tornadoes in the same meso. Again, we have a very large, intense circulation. And right here, with this outer one, we were looking at a DV of 145 and a DX of 1600. In other words, difference in velocity, 145 knots across 1600 meters. And that's kind of similar to what we saw with the El Reno storm. That very intense circulation. It kind of looked similar to this. And the NEXRAD radars are better at capturing this type of setup here. And I'll try to show you a couple, maybe one or two comparisons with the Doppler on wheels and the NEXRAD. Keep things moving along. Here we go. Here's a weird one. This is Stratford, Texas. This was that outbreak on May 15th, 2003. Again, very large, intense circulation there, and kind of a collection of embedded vortices in that one. This one here, yeah, this is Kellerville, 1995. Again, another example of concentric vortices, and this one was rapidly changing. And Gene Roden and Tim Marshall got some good footage of that one. And then here's some more examples of features that we see. This is strings leading into the vortex here, kind of almost like lines of vortices there. And then just moving things along here, this is a anticyclonic and cyclonic pair. This one was with the, which one was that? Oh, Glen Elder, Kansas. That was May of 2008 there. And then we've got the horizontal vortices, and you can kind of see that right there. That is probably a feature that forms on the leading edge of an RFD. What causes that is not really understood. In fact, there was a lot of skepticism that those things actually existed. And then there's another example of that right here. This is Canton Lake, Oklahoma, 2011. So maybe we can do a quick comparison of this. I've got GR level 2 up and I've got the data. So let me scroll through here and see what we can look at. I want to find an example of one that we can kind of compare. Let's see here, figure 7. Yeah, I think we can do this one. This is the Seward tornado, 2007. So let me load up GR level 2. That storm up there is not doing very much. So 2007, 05, 06. Now you can see that this is the older type of NEXRAD data, so it's a little bit coarser. And I'm trying to find where, oh, there's Seward, it's way up there. Yeah, it's almost impossible to pick out these features because we're at a pretty far range from the radar. This is 60 miles away, and once you get beyond about 60 miles, it gets very difficult to pick out tornadic features. Plus, you're up at about 6,000 feet there. So this is the storm that they were documenting there. There's the supercell, and what that actually looked like by the Doppler on wheels was this here. So right there, that's the hook at 0145, and you can see that very fine structure there. But with the WSR 88D, 0145, it looked like that right there. So yeah, the hook is in there, but we just don't have that good resolution with that particular image. What does the velocity look like? Let's check that out. Well, we can definitely see the couplet there, but this is kind of like the broad scale couplet. And if I was to measure this, I would find maybe a width on that of about 1.5 miles. So that's going to be a DV of about 2,000. So we're talking about a feature that wide there. So we're kind of sampling this part of the couplet, but the tighter, smaller, more compact structure, there's no way we're going to be able to pick that up with the WSR-88D radar. So I'm going to go ahead and wrap that up. Let's look at, again, that's fine scale radar observations by Warman and Kasiba. And one of the questions it raises is how you define a tornado. The conventional definition is any violently rotating column of air. But like right in here, you could probably make a case that there's multiple violent rotating columns of air. So is this one tornado, or is that 7 of them? And these are kind of worth studying because we do see elements of this on the WSR-88D radar. Like we'll see small elements, like I guess it barely picks up some of the structure at that coarser resolution. So there's a lot going on at these smaller scales, and hopefully the follow-on replacement radar for the WSR-88D will be able to sample that a little bit better. And I'm curious what they're working on as far as that goes. I think they were looking at phased array radars for the follow-on replacement, but I haven't really caught up on that too much. So let's go ahead and head into our forecast. All right, the high-resolution rapid refresh showing those cells out there around El Reno. Probably overdid that a little bit, but the trend is for that to dissipate. Not very much upper air support there, so that's going to be gone, and not much else going on. However, for tomorrow, we're going to be looking at maybe some potential. Let me get those products up and running. Bring up the NAM, and we'll bring up the dynamics here. So for tomorrow morning, that's going to be the picture right there. So the best jet energy is still way up to the north. And then by evening, looks like maybe a little bit of help coming out of far west Texas there. But for the most part, we're under the influence of this ridge throughout much of Texas there. So some of the best dynamics are going to be a little bit further to the west. And then for Sunday, looks like we could start getting a couple of weak waves moving across parts of the panhandles and Colorado, Central Plains there. However, most of the jet energy is still up to the north. And then let's see what things are looking like for Monday. Yeah, we're starting to pick up a few more waves. There we go. And the flow is starting to increase a little bit over the Texas Panhandle. So it's going to be kind of a gradual improvement as we go on through the weekend. And let's see what the NAM's got. All right, we start out and we've got that lee side troughing there, southeast Colorado. That's often where we find that. And of course we've got the front up there in Kansas and extending down to about Elkhart and then up to Denver. And then south from that we've probably got the dry line. Looks like the NAM breaking out a little bit of activity there along the Cap Rock, just west of Childress. Yeah, let's take a look at a forecast sounding there. Again, this is for tomorrow. Very steep lapse rate there. The moisture does look a little bit problematic. It's a little bit low. You can see we've got 50s dew points there. Can we get storms out of that? Let me see. 97 degrees, that's pretty warm there. Yeah, it's possible we can break that, but one problem we're going to have with temperatures like that is high LCLs. And you can see here the LCL values way up above 2,000. So that's going to be one issue right there, and the other is the weak flow. So not a whole lot going on for severe weather, but you're going to take what you can get after the way the past month has been. Then going into Sunday, there's our low right there. It looks like maybe a bit of a wave coming together there in Kansas. So that's a little stationary front there, dry line probably down along the Cap Rock. And then as the evening goes on, looks like we're breaking out a few showers there in western Oklahoma. Let's take a look at what the soundings look like. Still a pretty good lapse rate right there. Still some capping. And then taking 90 over 70. Yeah, there's still some capping there, but looks like the wind flow is still a little bit weak there. And the other problem is that as we get towards the evening, the NAM doesn't really break out anything in that region. So I'm not too sure if we have anything going on for Sunday. Well, actually, yeah, later on, maybe south of Dodge City, maybe a little bit of triple point action in that region there. So let's see what kind of parcels that stuff's getting. This is a forecast sounding around Alva. Classic loaded gun right there. Flow is weak in the upper parts of the storm there. It's kind of offset by this strong southeast flow right there. There's a little bit of shear there in the lowest 1 kilometer of the atmosphere. Shear vectors look to be kind of weak there. So this would probably be a day where we would get some hail, maybe a couple spin-ups there, and yeah, dew points mid to upper 60s. That depth there, that's about 4,000 feet of depth. That's probably enough to sustain stuff. So yeah, Sunday may have some potential there. And then going into Monday, there's that low right there. The front takes on more of a southwest to northeast orientation. And then by evening, looks like we get a little bit more widespread development. Western Oklahoma down to Lubbock there. Probably that cell right there. Northwest Oklahoma, probably the better environment since the moisture is heading up like that right there. A little bit more slim pickings there around Lubbock. And then let's go ahead and look at the long term. Okay, past the weekend. Let's see here. Lots of 60s and 70s making it up into the lower plains there. And then by Monday, yeah, there's that northwest southeast front there in Kansas. Looks like, let's see here, by Tuesday, the pattern doesn't change much. We still got that frontal boundary there in Kansas. And I think actually a lot of what's going to happen boils down to the upper level patterns. So let me bring that up here. So we'll look at the GFS for Tuesday. So we're not going to get any widespread severe weather in the plains until we start pulling that stronger upper level wind and maybe some upper level dynamics out into the plains there. So looks like not a whole lot's going on through the rest of the period. In fact, let me see what's going on here. Yeah, we're just kind of underneath this ridging here. And then it looks like we get one wave coming in for Wednesday. A little bit of troughiness in here for Thursday. Yeah, I think probably the potential will be going up around midweek. And then the pattern becomes more amplified here. Pretty good trough moving in. This looks a little bit more progressive. And it looks like it's moving northeast there. So again, this looks like another Central Plains severe weather outbreak there. Anyway, we also had this upper level disturbance there in Florida. Let's see what's going on with that. Yeah, that's going to be moving into Florida around late weekend into Monday and Tuesday. And that'll be creating some unsettled weather in that region. Then it looks like that kind of opens up and moves into the southeast U.S. around midweek. Okay, so now we have a better idea of what's going on aloft, and it looks like we don't have a whole lot going on, but I think that bit of subtle troughing coming in for early next week, I think that will help things out a lot. We don't want to totally overwhelm the air mass with a big trough, but we've really got to get rid of this ridge here. So let's see what's happening towards Tuesday. Okay, here's Wednesday. I think probably maybe some of the severe weather potential will be going up as we get into Wednesday there. So probably, yeah, you can see here, see that cyclonic flow there. That's a little bit more well developed than what we've seen so far. So that this is on Wednesday afternoon there, and we've got pretty good moisture off to the east. So probably some severe weather potential here Wednesday, Thursday. Then you can see we've got some north flow coming in there. That's probably the frontal boundary kind of gradually oozing southward, maybe being reinforced by a little bit of outflow. And then things get a little bit more hazy as we get towards the weekend there. Still looks like we're bringing the moisture northward. And yeah, that's Colorado low really gets going there, so looks like maybe western Kansas for Saturday the 19th there. And basically what I see here is opportunities all throughout the period from about Monday or so for about the next week or two. I don't see anything that looks like a big progressive severe weather outbreak, but I think there will be some potential here. And then, of course, we have that tropical storm off to the south. There it is down there, but it's not so aggressive bringing that north. It was trying to bring that up into Florida around the 21st, 22nd, 23rd, and that doesn't appear to be happening. But that could disrupt some of the Gulf moisture towards the end of the period. And you can see that easterly flow right there. That's shunting some of the moisture there into Mexico and not so much up into Texas. So we could see the moisture fall off a little bit towards the last week of May. And another boundary here. More cold Canadian air coming in for around Memorial Day. All right, that's about all I got for the program. So we covered a lot of ground there. Hopefully I didn't lose too many of you. I can see that during the journal feature, the viewer count kept increasing. That's always a good sign. When that starts dropping off, that tells me people are getting bored. So that's good to see. Okay, just scanning through the chat real quick. Ron Chalfant says SpaceX canceled a launch for May 11th. Yeah, SpaceX, they're building that space facility down there in Brownsville. I think that might come online here in the next couple of years, and we might actually be able to see a space launch down in South Texas one of these days. Looking forward to that. Okay, let me just read through this chat. 230 miles. Carl asking about that journal thing that we did. Yeah, I'm sorry, guys. I probably got... I might have misspoke there. What is it that I said? 230 miles wide. Yeah, that's not what I meant. I probably meant 230... I don't even know what I said. I'm sorry. I'm kind of out of it here. Jeff Krob says 2.5 kilometers. Yeah, that's probably more on track with what I was saying there. A little discussion there about Jarrell and Joplin. Ryan Toomey says, I've never seen anything quite like Jarrell before. Yeah, that was 1997. Violent tornado there, down around the Temple area. And yeah, I guess that's about it for me. So thank you all for watching the webcast, and I think we may be on break tomorrow, but we will be back on Sunday, and we'll look at severe weather potential for Sunday and the remainder of the week. So have a good evening, and we'll see you shortly. Take care.